I'm working at a company called Usergroup, two colleagues here today. And I'd like to give a small talk, about 20 minutes, about a project that I've been working on. And this is mostly like a philosophical talk. So you're not going to see a lot of code. I'm mostly going to talk about architecture. And so be prepared to find everything which is wrong, what I'm saying, and just shout it out or write it down and tell it to me afterwards, because that's what I would like to know. Like, it's the first time I present this in a big audience, kind of small today, unfortunately, but sorry, I guess everybody's on holidays. So I would really like to know what you think about it, and any criticisms will come pretty much. So yeah, I called it Walk the Line, you'll see later why. So first of all, I really think PHP programmers are the best programmers, because we managed to write programs, right, despite PHP. So, but we have a second disadvantage, and that's our bias. Like usually when you come to, or even worse, when you start programming with PHP, you have this whole idea of an application which looks like this. So it's a bunch of websites. And somehow they form an application, but it's really a bunch of websites, and that's called your web app. And then, of course, the most important thing is your big fat database in the background. And that's, I think, like 80% of all web applications. That's what they are. They're like websites or pages in front of a database. And like for me personally, it was hard to get out of this way of thinking about an application. Yeah, by the way, I'm going to use these arrows in a lot of diagrams, a lot of arrows. And what I mean by them is acquaintance or like dependencies, or they're not data flow or anything. They're like who knows about what. So the database doesn't know that it's used by a bunch of websites, but the websites obviously know about the database. So then smart people were thinking, okay, how can we improve this? So they came up with what they called an implementation of the module controller design pattern, and just said, okay, let's make a bunch of our websites that's called a controller, and they're not giving any output, they're using the other things they've used for output. And then, yeah, of course, we're going to try to put something in front of the database, so we're not going to work with raw or whatever, but have some nice objects in front of them. And for some reason this was called module controller. It's been around for a while. Fortunately now it's getting its way out of the community. But this is still there, right? This is still going around. I mean, I recently did a research on web frameworks, and there's an astonishingly big amount of web frameworks calling itself an MVC framework, and I don't know why, and it's still and they still do it this way. So how do other applications develop or think of an application? And who's working in other languages as well? So there's one, okay. A couple. So you might know this approach, like if you think about an application, you have this thing in mind, which is a bunch of services. So modules or components, or however we call them, that do stuff. And usually what they do is they facilitate the communication between some sort of data, which the user is interested in, and the user. So that's how they look at the application, and you have something talking actually to the user, because that needs to be interchangeable. By the way, that's where the MVC should be used. And also they have some component talking to the database. So this is a layered approach that has different layers. If it's well done, they're interchangeable. And usually you have like a user interface or UX or whatever it's called nowadays on the front. Then you have your actual applications or service layer in the middle. It's like the main part, and the sys is there in the very back. You got the storage. So maybe you've noticed I kind of favor the second approach, and I want to give you some reasons like why I think this is better. So that's the one on the left-hand side. First of all, it separates concerns. So you have one module actually which does the user talk, one module which does the storage talk, and then like it's more easy to separate the concerns. And most importantly, it makes this in-between thing visible. And I don't know if you've ever tried to work with one of these MVC frameworks, but it's really hard to decide each time when you have a new piece of logic where to put it, right? And I don't know if I'm the only one experiencing that, but and that's what I think, because and I always think there has to be something in between I'm not seeing here, and that's actually the service layer. And if you have a program using it, you're lucky. So and this approach makes it more visible, and also hides the details. So I'm not saying like this is wrong and this is right, stuff like that, but it has certain advantages, and it's mostly a shift in mind. I mean, you can use any framework to do any kind of program, and I mean, most allow it, but it's a way of thinking about programs, right? So the last point is it makes it possible, or it makes it easier to hide the details. And what do I mean by this is the details, and it's funny because Andreas, actually, I don't know who that is, Andreas Müller?
He's not here.
He's not here, okay. Well, he wrote a mail to the user group about a talk from Robert Martin about an architectural approach, which is like 20 years old, and he dug it up and was fascinated by it. And he talks a lot about this, and this talk was actually one of the things that got me really sparked of doing this project. And the details is the thing on the left and the thing on the right. So you can put them away. And actually, as programmers, we mostly want to not think about them. We don't care how the data reaches the user. We don't care how it's stored. We just want to write a good program, right? So this makes it possible to actually have something without the ugly details on the left and right. What happens here, we try to hide the details. Well, there's really nothing left to do, because it's all in the details. It's
I want that. Nothing left to do, it's great.
Yeah. So it's all in the details, so you have to worry about the details, you have to think it. And so what people did is, instead of hiding the details, they just say, okay, let's hide the database, right? Because the database is ugly, and we pay a lot of money to PHP developers. They don't have to be fluent in SQL, but they have, you know? So we hide the database, yeah? Nice idea. They call it ORM, so it's object relational networks, and that's really mostly what they are. They're not hiding anything. They just objectify it. That sounds anti-feministic, but yeah. So it's still there. It's still the database. It's still there. It's not really transparent. It's really transparent would mean invisible. That you can't see. You don't even know that it's there. And that's kind of what my idea was about. But first of all, why isn't it really transparent? So this is a piece of code, and if you've ever used any ORM, this might look familiar. You have a basic entity, the user, and basically it has an age. Nothing else for now, but it's okay. That's all I want to know about the user. I want to know how old they are. And this class extends the model, and this is usually what's the base class for any entity in those MVC frameworks is. And that's basically, it's called an active record approach, so the user can store himself, can retrieve himself, stuff like that. But if you are looking for a certain kind of user, you have to do something like this. You have to build a query, or you have a query language like DQL, or even lets you use kind of SQL. But that's what you always have to do, and there are a lot of strings in there, so that's kind of ugly. We have a class called user, and now there we have a string called user, what the hell, and there we have a property called age, and now we have a string called age again. I mean, this is really just SQL with a pretty trace, right? So those three things. We have the type coupling of the entity of the thing being stored in the storage system. We always, I mean, I've never seen an ORM without some kind of query language. And yeah, that ID in there, that screams like database, right? I mean, if you write a program without a database, why would you put an ID in an object? It doesn't make any sense. So this is where my new approach comes in. Let's start from scratch. So forget everything I said now. I was just ranting about everything that's wrong with the world. I mean, I enjoy doing that, but it's not getting anywhere, right? So new approach, yeah? Completely blank mind, we just have our application. And now an important part in this model is, this architecture is the domain model. And the domain model is pretty much the model of the MVC, but in a more defined way. So the application is basically the part where things is done, and the domain model is our entities. And I'm going to go a little into that. But first of all, I call this the object land. Okay, so only objects exist here, and that's what we like, right? We like objects because hopefully most of us, or whatever you want to call it. So how about the domain model? So this is just go over like the semantic of the domain model, so you know what I'm talking about later on. You always have a root, which is your starting point mostly, and then this root has children, and those children have children again, and you see that's a tree, right? So you have those parent-child relationships, and then you say that's not enough. What about the more connections between them, right? We don't want to put everything in trees, and that's all right because we have the references. But we have those two different kind of relationships, and that's really important because how do you add a new entity? Well, you build a new child. You can't add it by building a new reference. You have to put a child somewhere. And that's the same way how do you delete an entity is you cut the child-parent relationship, you make it an orphan, and it's gone, right? So now we have some references hanging there. And that's just something you have to be aware of. But this is not covered by the system. You know, it's like in the Linux file system. If you remove a file somewhere and you still have some links on it, then those links go when you try to call it. That's what happens. So it does have a right click. Who says it doesn't have a right click? There you go. So how does this look like in the application? In the application, it looks like this. Simply adding a user. I mean, this looks like this is almost too trivial to put on our slide, right? But that's how I want it to look like. Deleting looks the same. You just have ask a model to get a bunch of users, and then you remove the user you don't like. And building a reference is a reference in PHP. Couldn't be more simple. So this is all kind of trivial. How about querying? Querying is always a little more tricky. But remember, we're an object land. We query like this. I mean, nobody would do this in a database. But I would. Okay, you would. But we live in object land, so for each is our friend, right? We have a pretty address code for each. It's called the filter method. Basically the same. So, why can't we program like this? Why can't we, this would be a lot more readable than some query builders. This would be PHP, so you would have the full support of the IDE or whatever you use. And yeah, we don't need to use PHP. So can we do this? I mean, until now it was kind of a little bit dreamy. We were living in object land, and we have a problem. This is this guy over there. He doesn't live in object land. He's the user. We have a border between it, and I call it flat land and the object land, just to make separation. So the user obviously lives in flat land, and in between runs the line of serialization, and that's bad. So what we need is some way to get our nice objects to the user, and that's basically the problem of crossing the line of serialization. And we have our delivery system here, which talks to the user and knows about the application. Problem solved. I'm not going to. I mean, this works already, right? If you have a infinite RAM and infinite CPU, perfect. Yeah. And that's. I mean, you always have to start assuming that you have infinite CPU or infinite memory when you design a new architecture, but we don't. So we need this. We can't live without permanent storage. So we need a babysitter to kind of get the things across the line of serialization for the storage as well. And obviously the delivery system has to know about the persistence here to be able to understand what the user wants and tell the persistence system. And the persistence knows about the domain model, but the application doesn't have any outgoing, everything which is blue here. So the object land doesn't have any outgoing arrows. So this is the important part about this. Because it's self-contained, it doesn't care about its environment. It only cares about the object land. So, and again, the keynote from Bob Martin is really nice if you want to know how to solve the delivery system problem. which can be web or anything else. So I'm going to talk about the persistent. But first of all, just to get you a little used to this architecture, how does a request look like? We have a little package here. That's basically the serialized data coming in, so flat. Whatever needs to go to the persistent, because it's really object, goes there. Then it's inflated and sent over to object land, where they can happily do whatever object like to do. And then it's packed into response and going back. So this is still works, right? So basic request reply stuff still works, so we're on the safe side. So let's go into the persistence. And I don't want to go into huge detail here, so I'm going to make it really graphic. We have our serializer, is this. It's basically a class which does nothing else but put objects, serialize objects and deserialize results from the database, communication between this. So storing is kind of simple. I mean, a lot of ORMs do it this way too. You just go through your object graph, find the ones that's dirty, that needs to be cleaned, that needs to be stored, and send it over. That's easy. How about querying? Again, a little harder, but not that hard. So we stay with this, right? We get our posts like that. So this translates roughly to, let's use SQL for here, to a query like this. But how about those filters? Let's say we want to get a post of the type new, and of all the posts of this user. Then we would add a filter like this, but this filter we just serialize it as well, and it comes out as a nice little adding to your query. And then we have to send this query away, and back comes your results, and then we have to inflate the result. So that's how it generally works. And well, I started this project a couple of months back, and it's hard to find time in your full-time between your full-time work and other projects that everybody knows like this. So, but I've actually implemented all of this, and you can see it. And it goes even further. I have some advanced stuff which I haven't shown here, but that's if you want to go to an enterprise-style website, you need batching and you need caching a lot. And a nice little trick called preparables, which is kind of emulating threading. It works as well with this approach, which makes it interesting. So yeah, I put it up on GitHub. I'm really looking forward to feedback, and if anybody wants to contribute in any way, I mean, this is a fairly young project, but I hope it goes a long way. And yeah, so let me know what you think. Thanks. So now, anything? Or was it too fast?
How do you actually create the SQL?
I'll explain a little bit. So the idea behind is that you have a lot of queries. So there's I got a query object, which is like the very end of the whole SQL, of the whole persistence cycle. And basically everything the user does, all those requirements he states, like I want users, I want to have them this age, this is all defined as some sort of filters. And then these filters, they're just adding to those queries. So, and then in the very last moment, or in the moment you decide, you say, okay, now I actually want these users. Because before you just stated filters. Then the query is executed. So this is all, yeah. So this is where it happens in this query where it's like the final frontier, and if you push it a little further, it goes over the I/O to the database, but it tries to stay on the machine as long as possible. That's the idea behind it.
You know, there's a line pattern called data access object.
Yeah,
That's a bit similar to me.
yeah, it is very similar. So it's basically an implementation, but yet again, the difference is mostly the querying language, because that's really like if you want to look for something that makes this unique, I think it's the query language, because I haven't, like, at least on PHP, I mean this is used in other languages, but I haven't seen a completely native PHP approach on querying, so that's that would be the difference here.
I think what can be a problem with this approach is that it tends to generate inefficient SQL.
That's true. So you really need to make it optimizable. So it has like if you try to go to a general approach and find this silver bullet for that works for everything, it won't work, right? So, but it does work for a lot of cases. So, but you need to be able to plug in exactly where you need to optimize and say, okay, I have this special case or this special query, and I want to translate it in exactly this SQL. But only in this case. In all the other cases, do what you like, I don't care. But it's still, this happens in the persistent layer, not in the application. So the optimization is really is in the last instance.
Can I answer to that? Quickly, you can also just ignore that to create slow SQL, which is what always people do, and they're really successful. So you can copy that approach and look at whatever. Just go with it. Doesn't matter about new route, it doesn't matter. Just develop faster, don't worry about it. It works as well.
Until it doesn't, and then you need to change. But go a long way usually.
Right.
But not all the way.
Right.
Yeah, definitely. Okay.
So how do you handle joins which are not aligned with the tree?
Again, sorry?
So how do you handle those joins which are not aligned with the tree?
They are all in the data tree. Is that in the domain model that's agreed?
Yes, but if you are not joining a parent and a child, but two different points on the tree.
If I
So you have a bunch of objects on one point of the tree, and they are related to some other point of the tree, and you want to get all relations for the related objects.
so there needs to be some kind of relation parsing if you want it generically. If you can do it specifically for one object, then you just know about its brothers and sisters and the people it's related to. But I mean, there are approaches nicely. So either you put it in annotations or in configuration where you say, okay, listen, this guy has an end-to-end relation with those people, and you configure it so your persistent engine knows about it, or it tries to find it out by itself. And I personally like the PHP annotations, and I'm trying to use those to find out the relations.
Didn't you say that the design point of this is that you leave all the resistance information out of the domain?
I'm not trying to get to hide it completely from the developer. I'm just trying to hide it to get it out of the application layer as far as possible. It doesn't. I don't think it's possible to write a piece of code that makes you not worry about the database anymore, because you still have to, but you can do this in a completely separated part as where the action is going on. I hope this is what you were.
Yeah, but basically this seems just data mapper with a very nice interface.
Yeah, it's a pretty nice interface. That's what I'm trying to reach. I only care about the interface. I'm not trying to break ground here on any new technologies and systems.
It sounds a little bit like an object relational mapper. And did you have a look at Doctrine?
Yeah.
It looks similar.
Yeah, Doctrine is making. I like it. I mean, we're using it at the moment. But yes, again, the querying. I mean, if you want to query in Doctrine, you have the options of the query builder, SQL or EQL, and also you have your ID still. So if you and the third point is, although it kind of has a little trick to get across paradigms connections, so between NoSQL and SQL, for example, this is kind of really artificial. So I would like to have a bigger approach here, where it doesn't even you don't even care which kind of database is plugged in behind your data. It works either way, but the same engine. And this is some of the downtime points of Doctrine. But besides that, and it doesn't work that well on longer running scripts either. Yeah. There's a lot of memory issues.
Longer running script.
Yeah, try it. It doesn't.
Okay.
We've been trying really really hard to find those memory leaks, and they just keep popping up. It's a nightmare. Yeah. All right.
I like the concept of the services and the data, where you've got the multiple services. But would this play nicely with the sort of application where you've got multiple services with different data storage, different databases behind them, basically? It seems to me that like your straight line layers architecture, your services, is, the link between the UX and the data is sort of even more abstract than when you're sort of bringing a little bit of knowledge of the data structure into your application. Basically, would it play nicely with multiple data sources, which might have completely different structures?
Yes, as long as they have some sort of understanding of what an entity is. So what, like if they have, but I mean, document-based databases have that, and the table-based database have the. If you have any key value storage, it works as well. So, but I mean, if it comes to if you're using web services in the background as a storage, and then it might have some tricky side effects, but I haven't tried it yet, so I don't know. But it should work with all like entity-based databases. Let's call it like that. So yeah. All right. Thank you very much again, and I'll be here for you.